Hey everyone! In this video we're going to explain about functional group. So what is functional group? A functional group is an atom or group of atom that is primarily responsible for the properties and reactivity of a given organic compound. Functional groups refer to a specific atoms bonded in a certain arrangement that give a compound certain physical and chemical properties. In this video we're going to explain about 6 major functional groups in high school learning, which are alcohols, ethers, aldehydes, ketones, carboxylic acid, and esters. The first we're going to explain about alcohol. Alcohol is an organic compound that contains one or more hydroxyl OH group. So, incorporation of an oxygen atom into carbon and hydrogen containing molecules leads to new functional groups and new families of compound. When the oxygen atom is attacked by single bonds, the molecule is either an alcohol or ether. So, alcohol are derivatives of hydrocarbon in which an OH group has replaced a hydrogen atom. Although all alcohol have one or more hydroxyl or OH functional group, they do not behave like bases such as potassium hydroxide and sodium hydroxide. Sodium hydroxide and potassium hydroxide are ionic compounds that contains OH ions. Alcohol are covalent molecules. The OH group in an alcohol molecule is attached to a carbon atom by a covalent bond. So these are the steps for naming alcohol. The first is name the parent compound by finding the longest continuous carbon atom chain that also contains the hydroxyl group. Change the final E in the name of the alkene into O. Number the parent carbon chain in a way that makes the sum of hydroxyl number as low as possible. Add the numerical prefix into the name before the name of alcohol, and then we separate numbers with commas and separate numbers from names or prefix with hyphens. There are no spaces in the name. Now we move into the example. So this is methanol. Methanol is come from methana, which are the chain is attacked by oxygen, so the oxygen is come to here. So the OH group is bonded into C with a covalent compound. Then the A here is changed into O, methanol. Same thing happens to ethanol. In ethanol is an alcohol consists of which have 2 carbons. It came from ethana. In alcohol it becomes an ethanol. Now let's jump into the fourth example. As we can see here, this is the functional group OH. The C here is bonded. Then we count the longest chain, which will become the parent chain. We can count it into like 1, 2, 3, 4, 5. Then we get a butanol. So this is the chain, right? It comes in the C number 2, so we can write here 2-methyl, and because the OH is bonded into C number 2 from the least number, it becomes 2-methyl 2-butanol. So aliphatic alcohol is divided into 3. There are primary alcohol, secondary alcohol, and tertiary alcohol, as we can see here in the example. So what is primary alcohol? Primary alcohol is when the OH group is bonded into C, which are only bonded into one another C. As we can see here, the C that is bonded into OH is only bonded with one C. That is called primary alcohol. In secondary alcohol, as we can see here, the C that is bonded with OH is bonded into 2C, CH2 and CH3. And then the same thing happens to tertiary alcohol. 1, 2, 3. So the properties of alcohol. The smallest and lightest alcohols such as methanol, ethanol, and propanol are completely soluble in water in all proportions. The hydroxyl group of the alcohol undergoes hydrogen bonding. The stronger hydrogen bonding between alcohol molecules means that more energy is required to convert liquid into vapor, resulting in significantly higher boiling points. Alcohols are commonly found in many everyday materials such as acetone as a nail remover and alcohol that we use every day, such like that.
Now we continue to the ether. Ether is organic compound in which two hydrocarbon groups are bonded to the same oxygen atom. So this same oxygen atom can bind two hydrocarbon groups or specifically as alkyl or aryl. Steps for naming ether. The first step is the word ether appears at the end of the name. For example, blank 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 ether. The second one, the two hydrocarbon groups are named using the rule for alkyl substituents, and these names come before the word ether. For example, I take two alkyls, namely methyl and ethyl, so the name should be ethyl-methyl ethers. For the same alkyl, namely methyl and methyl, the name is dimethyl ether. And the last one, spaces are left between the names of the alkyl groups if different and before the word ether, just like the example before, ethyl-methyl ether. Examples of ethers. The first example is dimethyl ether, because in this compound have two alkyl, namely two methyl, so the name should be dimethyl ether. This one is diisopropyl ether because there are two isopropyl alkyl. And this one is diethyl ether because in this compound there are two ethyl alkyls. So actually, ethers also called as alkoxyocane. So dimethyl ether also called as methoxymethane. Properties of ethers. Ethers are somewhat soluble in water, but less so than alcohol. Second, the solubility is greater for ethers that have shorter R groups. Dimethyl ethers have the shorter R groups than the isopropyl ethers, so dimethyl ethers has the greater solubility than the isopropyl ether. The boiling points of ether are much lower than the boiling points of alcohol. It causes in ethers there is no hydrogen bonding, but in alcohols there is hydrogen bonding. So it makes ethers have much lower the boiling points of alcohol. And the last one, ether molecules do not have hydrogen atoms that are covalently bonded to a highly electronegative atom, and so ether molecules cannot form hydrogen bonding with each other. In alcohols, a highly electronegative atom, namely oxygen, form a covalent bonding with hydrogen, so it forms hydrogen bonding. But in ether, the oxygen is not bonding with the hydrogen, so it cannot form hydrogen bonding with another ether.
So now we move into aldehyde. Aldehyde is an organic compound in which the carbonyl group is attached into a carbon atom at the end of a carbon chain. This is the functional group of aldehyde. Aldehyde contains the functional group, the C that has double bond into O. Aldehydes are organic compounds which incorporate a carbonyl functional group, CO. The carbon atom in this group has two remaining bonds that may be occupied by hydrogen, alkyl, or aryl substituents. If at least one of these substituents is hydrogen, the compound is an aldehyde. If neither is hydrogen, the compound is a ketone. So now we move into the step for naming aldehyde. First, name the parent compound by finding longest continuous chain that contains the carbonyl group. Let's jump into the example. So the first, we're looking into the parents. This is the functional group. Then we're naming the parent chain. We're looking into the longest chain that is possible. 1, 2, 3, 4. 4 is the longest parent chain. So butanol is the parent chain, and then the other substituents is methyl and methyl. Change the E at the end of the name into the alkene to all. So this 4 is butana. In hydrocarbon, in alkana, it is butana. In aldehyde, we change it into all at the end, so it becomes butanol. And then if other substituents are present, begin numbering the parent chain on the end where the aldehyde is found. These are the other substituents. It's dimethyl, placed in 3. Actually, it is 3, right? I'm sorry for the mistakes. Yep. So it's 3.3 dimethyl butanol. 3.3 dimethyl 1, 2, 3, 4 butanol. Also work with this because it doesn't have any other substituents, so it's just butanol. Then this is a kind of trivial name in some of popular aldehyde, such as formaldehyde. Formaldehyde is the simplest aldehyde. It is only contain one carbon atom that is attacked with aldehyde. So formaldehyde is actually a methanol. And then acetaldehyde, that is aldehyde that contains two carbon atoms, which is actually a ethanol. And then there is propionaldehyde and butyraldehyde, 3 carbon atoms and 4 carbon atoms. And these are some popular aldehydes that we may be found in daily life. So the properties of aldehyde. Aldehydes can participate in weak hydrogen bonds with water through the carbonyl oxygen atoms. The smallest aldehyde, 3 carbons or fewer, are soluble in water in all proportion. As the length of the carbon chains increase, water solubility decreases. Because the more carbon, the compounds will be more non-polar. And then aldehydes cannot hydrogen bond with themselves because they do not contain any hydrogen atom in sufficiently polar bonds. As the result, their boiling point are generally lower than those of alcohols. Aldehydes are polar molecule due to the polarized carbonyl group. Methanol, also known as formaldehyde, was once commonly used as a biological preservatives for dead animal. In recent years, formaldehyde has been shown into a carcinogen, so safer alternatives are often used instead. And then aldehydes are also used in the production of resins and plastics. The simplest ketone, propanone, is commonly called acetone.
So here is ketone. Ketone is organic compound in which the carbonyl group is attached to a carbon atom within the carbon chain. Steps for naming ketone. First, name the parent compound by finding the longest continuous chain that contains the carbonyl group. change the "-ete" at the end of the name of the alkane to "-on". Example: this compound has 6 longest continuous chains, so it should be hexanon. Second, number the carbon atoms in the chain so that the carbonyl group has the lowest possible number. So let's number this compound. If we start from the left, it should be 1, 2, 3, 4, 5, 6. So the carbonyl is number 3. If we start from the right, it should be 1, 2, 3, 4. The carbonyl is in the 4th position, so we should start it from the left, and the carbonyl is number 3. And the third step, add the numerical prefix into the name before the name of the cation. We add the prefix 3 before hexanon, so it should be 3-hexanon. And the last one, use a hyphen between the number and the name of the ketone. So we use the hyphen here. And because in the 4th carbon has the methyl or alkyl, so we should insert 4-methyl, and this compound is named 4-methyl-3-hexanol. Examples of some ketones. First, 4-methyl-3-hexanol. Second, 2-butanol or ethyl-methyl ketone. This is 2-butanol because if we start number it from left, it's 1, 2, and we start from right, 1, 2, 3. So it should be in 2, and the ketone or carbonyl group is in the second number, so it should be 2-butanol. Or ethyl-methyl ketone. This is ethyl, and this is methyl, and this is ketone. This is acetone, or we know as 2-propanol, and this is acetopenol. Properties of ketone. First, ketones can participate in weak hydrogen bonds with water through the carbonyl oxygen atom. From these carbonyl groups, oxygen here can form a hydrogen bonding with water, but it's a weak hydrogen bonding. Second, the smallest ketones, 3 carbons, are soluble in water in all proportions because 2-propanol has similar traits with water. As the length of the carbon chain increases, water solubility decreases. The longest carbon continuous chain, so solubility in water is decreases. Third, ketones cannot form hydrogen bonding with themselves, or we know it as intramolecular hydrogen bonding, because they do not contain any hydrogen atom in sufficiently polar bonds. As a result, the boiling points are generally lower than those of alcohols. So in here, the bond is covalent bonding, but the covalent is non-polar, so the oxygen cannot form hydrogen bonding with H here. So in the ketone, it could not form an intramolecular hydrogen bond. And the last one, acetone, or as we know as 2-propanol, is a common organic solvent that was once used in most nail polish removers, but it has largely been replaced by other solvents. So in organic solvents, not only acetone we use, but also benzene or N-hexane.
So, carboxylic acid. Carboxylic acid is an organic compound that contains the carboxyl functional group. A carboxyl group, or COOH, is a functional group consisting of carbonyl group CO. As we can see here, this is the CO, C that has double bonded with oxygen and with a hydroxyl group or OH attached to the same carbon atom. Carboxyl group has the formula COOH, usually written as COOH or CO2H. Carboxylic acid are a class of molecules which are characterized by the presence of one carboxyl group. And then we move into steps for naming carboxylic acid. The first, find the longest continuous chain that contains the carboxyl group and name the parent chain. And then we change the E at the end of the name of the alkane into oic acid. If other substituent is present, number the parent chain that the carboxyl carbon atom is first. Now we jump into the example. Metanoic acid, it is very simple, it's from methanol, and we change the A into oic acid, then it become metanoic acid. Same with ethanoic acid, propanoic acid, butanoic acid, and pentanoic acid. While in this, it has become more complicated, but it is not the IUPAC name, it's more like the trivial name. Propionic acid, butyric acid is the IUPAC name, or still the IUPAC name, but the others has our trivial name, but it is the acid that we may be found in daily life, such as lactic acid, acrylic acid, citric acid, fumaric acid. We must be frequently hearing that, right? Then the properties of carboxylic acid. Carboxylic acid are all weak acid, meaning that they do not fully dissociate to produce H+ cations in a neutral aqueous solution. And the smaller members of the aliphatic carboxylic acid series are colorless, volatile liquids with strong odors. Carboxylic acid with shorter carbon chains are very soluble in water, while those with longer carbon chains are less soluble. Carboxylic acid can form intermolecular hydrogen bonds, so they have relatively high melting and boiling points compared to other organic compounds. They cannot bond a hydrogen bond.
And the last functional group is ester. Ester is organic compound that is a derivative of the carboxylic acid, in which the hydrogen atom of the hydroxyl group has been replaced with alkyl. So, from the hydroxyl group, before our accent, here is H, or we know the accent is carboxylic acid, but by the way, clarification, carboxylic acid and alcohol are reacted and form ester, and H here is replaced or substituted by the R accent, so it produces ester. The reaction field is called esterification reaction. The COO here is carboxyl group. Steps for naming. First, identify and name the alkyl group that has replaced the hydrogen of the hydroxyl. This is the first part of the ester. For example, of the alcohol, we use ethanol. So, the alkyl of ethanol is ethyl, so we should replace the ethyl with the hydrogen from the hydroxyl group. Second, name the carboxylic acid portion of the molecule COO by changing the ending of the name from oic acid to OI. For example, lactic is ethanoic acid. After remove and the H and replace the alkyl, so butanoic acid, it should be butanol. And the last one, leave a space between the alkyl group name and the name of the carboxylic acid derivative. So the carboxylic derivative of ester is this react between carboxylic acid and alcohol. The carboxylic acid is the acid, the alcohol is ethanol. After replace the ethyl from the ethanol by replacing the H with the carboxylic acid, at last the ester name is ethyl methanolate. Examples of some esters. First, ethyl propanoate. Ethyl propanoate is come from the ethanol and propanoic acid. This is ethanol, this is propanoate. This is propyl methanolate. Propyl is come from methanol, propanol, and the methanolate is come from methanolic acid. This is methyl methanolate. The methyl is come from the methanol, and the methanolate is come from the butanoic acid. And the last is propyl ethanol. This propyl is come from the propanol, and the ethanolate is come from the ethanoic acid. The propyl from the propanol replaces the H from the ethanoic acid, so it forms the propyl ethanolate by reaction of esterification. Properties of esters. First, esters have lower boiling points than the carboxylic acid. Second, esters with very short carbon chains are somewhat soluble in water, while those with longer chains are less soluble. A very short carbon chains of esters is methyl methanolate. So methyl methanolate is soluble in water because that ester have the similar traits with water, but the long carbon chains ester is insoluble in water because there is no similar traits with water. The last one, esters are very commonly found in plants and are sensible for many if others and flowers. For example, in this, I think this is cherry fruit. So in the cherry fruit contains esters, namely methyl salicylate, and in this pear fruit contains ester, namely propyl ethanolate. So that's all our explanation about our material, namely functional group. For any confusion, you can ask us in the comments column. For your good attention, we say thank you.